What is up, people, and welcome to another video on the Kubernetes Lightning series. So far in this series, we've taken a look at Docker, we've built our first container, we've taken a look at installing kubectl and creating a lightweight Kubernetes cluster using a utility called kind that we can use for local testing. After having a small cluster running locally, we use kubectl and we learned how to configure kubectl to access our cluster. Then we learned the fundamentals of YAML, because YAML is the way we will be describing our desired state, our infrastructure that we want to deploy to Kubernetes. Then we learned about all the different Kubernetes objects, starting with pods, deployments, secrets, and services. And there are more objects to go through, but I thought it would be a good idea to stop and look at a popular tool for Kubernetes. When exploring Kubernetes, you've probably come across a tool called Helm. So what is Helm? In this video, we'll take a look at what Helm is, what it's used for, why it is so popular. We'll take Helm for a spin and I'll show you its power. So without further ado, let's go. So we'll start this video by taking a look at our GitHub repo. In our GitHub repo, we have a Kubernetes folder. If you expand that and you go down, you'll see we have a Helm folder with a README. Now this video is all about our introduction to Helm. And in that video, I basically go through getting started with Helm and we focus on creating our first chart. And I basically show the power of Helm and how we can package up our application, take all our YAML and define a chart, and then use that and then use Helm features to deploy that chart to our cluster. There's a link to that video down below. I'll touch briefly on some of the features of creating our own chart, but there is a video in the link down below where I go into a lot more details. So be sure to check out the link down below to the source code so you can follow along. So now that we have the source code, what we're going to do is create a lightweight Kubernetes cluster that we can use for testing. If you've been following this series, you know that I like to use a utility called kind, which allows me to create lightweight Kubernetes clusters in Docker containers that I can use for testing. It allows us to create really small Kubernetes clusters, and we can run multiple of them without any virtual machine. They're really quick to spin up and we can just delete them when we're done. You can have multiple of these running on your machine for different projects. So what I'm going to do in our source material, I'm going to scroll down, and here is our section where we create a Kubernetes cluster. So we say kind create cluster. I'm going to call this cluster Helm, and I'm going to run Kubernetes 1.31. I'm going to go ahead and copy this, jump into my terminal and paste that, and that will create a lightweight Kubernetes cluster that we can use for testing. And now that that is done, I can say kubectl get nodes, and we can see we have a 1-node Kubernetes cluster, and if we give it some time, the Kubernetes cluster will become ready. Now that we have a cluster running, we're going to need the Helm command line. Now it's important to know when working with Kubernetes, generally when you run other command line tools, they will assume that you have a kubectl setup with a kube config pointing to the cluster you want to work on. The Helm command line will always run against the cluster wherever your kube config file is pointing to. So given we've covered kubectl in our previous video, we've created a kind cluster, our kubectl kube config is automatically configured to point to that kind cluster. But you want to do kubectl get nodes and just make sure you're pointing to the right cluster before you continue. Helm will automatically point to the same cluster. So what you want to do is head over to the Helm website. You can find it at helm.sh. This will take you to the home page of Helm, and then head over to docs. Once you're on the docs page, just scroll down and go to the quick start guide. The quick start guide will talk about the prerequisites that you need access to a Kubernetes cluster, and then you'll find the install Helm section. And click on this link. This will take you to the official GitHub release page. Once on that page, you can see this is the version at the time of this recording. And what you want to do is just download the CLI for your platform here. So I'll be using the Linux AMD version. So I just right click and I basically just went and copied this link, and I have documented it in the source material. So I'm going to be using curl to download that release by pasting that URL that I copied from the GitHub releases page. And that's the version number we'll be grabbing. Then I use tar to extract it. I'm extracting it to a temp directory, and then I'm moving the Helm binary into user local bin, giving it execution rights with chmod. So I go ahead and copy this, and once I've copied that, I can jump into the terminal and paste it. And that will go ahead and use curl to download it, use tar to extract it, and then move the Helm binary into user local bin, give it execution rights, and then I can type Helm, and we can see now we have the Helm CLI installed. Let's walk a few steps back. What is Helm? So Helm is basically a package manager for Kubernetes. So what does that really mean? Helm is a package manager for Kubernetes. So it manages Kubernetes packages. Now we know when we deploy to Kubernetes, we deploy Kubernetes objects, but we describe them using YAML files. So basically Helm is a package manager for YAML files. Basically, Helm packages YAML files. That's what it does. This is kind of obvious because we know already from working with Kubernetes that we needed a pod YAML, a deployment YAML, a secret, a service YAML, and there are more YAMLs we'll take a look at in future videos. So we need to group all these YAMLs up to create a package out of it. So that is pretty much what Helm does. It allows us to group all the YAMLs we learnt about in previous videos together. And how does it do this? Well, this is where the command line comes in. We say Helm create, and then we give it a name. So we create something that Helm calls a chart. And basically what this does, there's no real magic behind it. It simply packages the YAML by placing them in a folder. And this specialized folder is called a chart. So once we run the Helm create command, we give it a name of what we want to call our chart, and then it will create a folder with a few metadata files inside. And this folder is basically called our chart. So the chart is just a fancy name in Helm for a folder. And when we take a look at that, it's just a folder called my chart, and then it has our YAML files inside. Now, how different is this from just using kubectl? Because we remember in our previous guide, we can do kubectl apply, we can say -f and pass a YAML file, or we can pass a folder. So before Helm was around, that was the way to deploy. You would group all your YAML in a folder and then say kubectl apply that folder. The problem with that is that you need to copy each folder if you want to change the values between development clusters, staging clusters, and production clusters. So this is where Helm kind of helps out. So instead of saying kubectl apply -f and point it to a folder, we now say Helm install that folder. But how is that different? Why do we do that? This is because if we used kubectl apply -f and we had a dev cluster and a staging cluster and a production cluster, and let's say we only run 2 replicas in dev, but we need 10 replicas in prod. Or sometimes things like DNS and domain names, SSL certificates, and things are different between development, staging, and production. If we used kubectl apply pointing to folders, we'd need to duplicate our YAML between environments, and this is not cool. So that is why we'll use Helm install instead. This is because Helm allows for customization, which is by using a thing called a values file. So how does it do this? We can in theory take our chart and then create the differences in a much smaller YAML file. So let's say our dev cluster had 2 replicas, but our production cluster had 10. We would only define the replica number in what's called a values file. So you would have all your YAML sitting in your chart folder, and then you would supply a values file for each environment. And that means you can kind of augment these Kubernetes objects before you deploy them to your dev, staging, or prod cluster. Now, how does Helm do this? Helm does this by what's called templating. Helm is just a fancy template generating engine. It's a package manager as well as a template engine. So basically what we would do is, instead of this, remember in our previous video on pod.yaml, I'm just using pod.yaml here as an example, but you could use any type of object here. We had pod and we had the name and namespace default, and the name was example pod. Now let's say in dev, this might be different to production, or you could be using a deployment over here with replicas. Instead of hard coding the names and the namespace and the replicas over here, you would instead do something like this. So in your pod.yaml, you would specify basically a template style syntax. So this is how you define a template in Helm, or a placeholder. So you use the double curly brackets, open and close, and then you can write Helm syntax inside. Now be sure to check the link down below to my previous video on Helm, where we actually deep dive and build our first custom Helm chart by grouping all the YAMLs we had in the previous videos. If you would like me to repeat that and create a video specifically on designing and creating your own Helm chart, let me know in the comments down below. But it's pretty straightforward to do that. So instead of hard coding, we put these placeholders here, and this tells Helm that all these values are coming from what's called a values file. And once we have our chart defined like this, we have to go ahead and define values for each of our environments. So then we could have something like our chart, which we saw at the top here, and then we can have a values file for dev and a values file for prod. And you only place the values you'd like to override. So you can either rely on the defaults for dev, but then in production you can override it, or you can override it on each environment. And this allows you to inject things like different replica numbers for different environments, different domain names, different secrets, or what have you. So once you have all of this, how do you deploy it? Well, you just use the Helm command line to do the deployment. And this is what the Helm command line looks like. We basically say Helm install and then the name of the chart, and then we put our values file like so. And this will go ahead and run the Helm install command against the cluster that your kubectl is pointing to. And we will supply the appropriate values file we want to deploy. Now in the video that I linked down below, our introduction to Helm, I actually extensively go through a process of creating our own chart from scratch. And in there, I take you through the process of combining different YAMLs, and they are exactly the same YAMLs we used in the previous videos on this Kubernetes Lightning series. So the pod, the deployment, the service, the secret, and a couple of extras. We take those YAMLs and we combine them in what's called a chart. And I briefly wanted to show you what a Helm chart looks like before we go ahead and look at an official chart. We ran this command called Helm create, and you give that Helm create command a name of a chart. We can type helm create -- help to see the command, and it's helm create, and it takes a name. This command creates a chart directory along with common files and directories used in the chart. So if you said helm create foo, it's basically going to create a folder like this. So I wasn't joking when I mentioned that a Helm chart is just a folder. You can actually create this manually. You don't need the Helm command line. It's a folder, then it's a Helm ignore file, which contains pattern to ignore when packaging Helm chart. This functions similarly to a git ignore file. Then you have char.yaml, which is information about your chart, values.yaml, which is all the default values for your template. And it's cool to define default values because when someone who wants to consume your chart look at your chart, they want to see what is customizable. So they'll take a look at your values.yaml to see what they can change. And we'll take a look at an official Helm chart and you'll be able to see this. Then you have the charts folder, which is any charts that this chart depends on. We know that Kubernetes is a complex ecosystem and sometimes one Helm chart may depend on another Helm chart. For example, you might set up your monitoring where you deploy Grafana, but in order to deploy Grafana, you might want to deploy Prometheus. And to deploy to Prometheus, you might want to deploy a couple of other operators. So you might have all these Helm charts connected to one another. This allows you to do so. And then you have the templates folder, which is just where the YAMLs go. So in my Helm video, I actually run through this and I create a chart called example app. So if you open up the source code and go to Kubernetes folder and go to the Helm folder, you'll see this example app chart right here. And you'll see the exact folder and file breakdown we saw earlier. So you got the templates folder, and in here you've got all the YAML files that we've covered as part of this Lightning series. You've got service, secret, deployments, and config map. Now config map is not something we covered yet. We'll cover that in a future video, but these are all just Kubernetes YAMLs. So to create your chart, you simply say Helm create and create your chart, which will create this folder structure, and then you just simply paste your templates in here and you pretty much have a chart. Then you can go to the chart.yaml, and in here you can define your chart by giving it a name and a description. You can give it a type, what this Helm chart represents, the version of this chart, and the application version. So this could be the version of MySQL that you might be deploying if you're deploying a MySQL Helm chart. And this is just the version of all your YAML files. So it's independent from the actual application. And then if we open up the deployment YAML, you'll see that here are the placeholders I mentioned earlier. So instead of hard coding everything, you would define these placeholders, and this allows the consumer of your chart to create a values file where they can inject the name, for example. We kept this example really simple, so we just replaced the names on everything. We've got config map where we replace the name, we've got secret where we replace the name, we've got service where we replace the name. And these three examples are three application values files. So you can either have values files for your different environments, or you can have them for separate applications. So here you can see I have one for application 1, which is called just example app, and it's got the image it wants to run and the tag. These are all the overrides that will inject into our chart. And then here we have a second one, which is example app 2, and here we have another app called example app 3. So the guide talks about creating this chart and how to add Kubernetes files to our chart. So we go and hand pick pretty much all the YAMLs we've taken a look at in previous videos and copy them into the templates directory. And then I walk through the Helm install command, so how you install a Helm chart. So we can actually go ahead and run the Helm install command and test this installation process, and I can show you what that looks like. If we type helm install -- help, we can take a look at what this install command looks like, and it's documented quite well. So this command installs a chart, and it gives you quite a few examples. You can say helm install, and here you pass the values file, and then you can deploy something like Redis. You can point to a folder. There's a whole bunch of examples here in the help command, but basically what we're after is the usage guide. So you can say helm install, then you put the name of the release. Whenever you install a Helm chart, it creates what's called a release, and then the chart name, and then any flags or options you want to pass, and these are all the options here. One of them is -f or -- values, and this allows us to inject the values file that we'll take a look at in a bit. To install this example app chart that we've taken a look at, we can change directory into our Kubernetes Helm folder, do ls, we can see our example app folder is right here, and then I can say helm install, and I want to call my release example app, and my chart is example app. It's this folder located over here. And then I'm going to say -- values, and I'm going to pass a values file, and I have an example values file in the example app 01.values.yaml. Gonna go ahead and run this, and you'll see it'll give you back some feedback. It'll give back the name of the release, the revision, and the revision number is important because that's what you'll use to roll back. You can use the Helm rollback command to roll back to a previous revision. It gives you the namespace and the status. You can see this has been deployed. So I can run kubectl get all to kind of see all the resources that's been deployed. Kubectl get deploy will show us there's our example app deployment. So to summarize, this Helm install command basically took this name here for our chart, and because this chart doesn't live on the internet, it's just a local chart in a folder, it took the YAML in that templates directory, transformed it using the template generation engine, injected the values we provide, and then rendered new YAML out and applied it into our cluster. That means that this Helm install command would have gone ahead and deployed all the YAML inside of this template. So config map, a deployment, a secret, and a service. And we can see those resources here. I can then say Helm list, and that'll show the releases. So we can see we have this example app in the default namespace, the first revision, and it'll give some timestamp on when it was last updated, and a status being deployed. If I wanted to make some changes to either my Helm chart or roll out a new Docker image, I can go ahead and make changes to either the values file or the YAML. Let's say I go into my Kubernetes Helm folder, go to this example app templates, open up the deployment, and let's say I don't want to hard code replicas to 2. I can do something like this. I can say value, and under here I can say deployment dot replicas. And I can also do this and say pipe and put default as 2. So this is the capability that Helm provides. It's actually very powerful in terms of template generation, and it has a lot of features. So here I'm just saying that I can look for a values file under deployment replicas. If it's not there, just default to 2. That means I can go and take this replica's number. I can head over to my YAML or my values file, and I can add a new parameter, and I can say I want 5 replicas. Go ahead and save that. Now to upgrade my Helm release, I basically, instead of using the Helm install, I use the Helm upgrade command. So to do that, I can just jump back to the terminal, and it's basically exactly the same as the Helm install. This time we just say Helm upgrade, the same release, the same chart, the same values file. And this time when I run it, you can see now it's upgraded. So now the revision is 3, and the revision will keep bumping up as you make changes. If you want to roll back, you can do Helm rollback, and you can simply specify the release you want to roll back and the revision you want to roll to. So now we have an understanding of the basic overall feature of Helm, how it allows us to group YAML files together and use its very powerful template generation capability to override values for different environments in Kubernetes. So it essentially allows us to build a generic package that we can deploy to different clusters. So that is the true power and capability of Helm. But how is this power utilized? So one thing companies may do is build Helm charts for microservices or storage services like databases that teams can then reuse and pass in values files for each of their microservices. But I think the most popular way Helm charts are used is for open source applications. Things like an ingress controller, things like a service mesh, monitoring components like OpenTelemetry, Prometheus, Grafana, SSL cert managers, autoscalers, and the list goes on. The power of Helm is that it actually becomes a standard. It's really simple to take open source packages and then deploy them to your cluster, and it's very easy to go and have a look and see what you can override, because as I mentioned before, there's a templates folder with all the YAML. You can go ahead and look at that. You can then also go ahead and look at the default values file that the community supplied, and this allows you to see how you can override certain fields and customize the deployment. So as an example, I'll take you through what an ingress controller chart looks like and how you can analyze a chart, deploy it, and override and make changes. And you can apply this concept to any Helm chart in the future. So I will use one of the most popular ingress controllers, which uses Nginx, and it is built and maintained by the Kubernetes maintainers. I'll use that as an example. So I just go ahead and search for that. You'll find this on GitHub. This is under the Kubernetes community. It's the Ingress Nginx repository. And this is pretty much what a GitHub repository would look like for basic Helm charts. This is the Ingress Nginx controller. They have getting started document. And one of the things I like, and you should find this on every Helm chart repo, is actually the version of the software and then the supported Kubernetes versions. I always like to check this before deciding on what Helm chart version to deploy. So here you can see the latest Kubernetes supported versions are over here. It has the latest Nginx Ingress version. Here is the version of the OS as well as the Nginx version. So this is the Helm chart version we'll be looking for, 4.12.1. So take a note of that. It's important when deploying Helm charts to your cluster to know that generally Helm charts are tied to the version of Kubernetes. So you want to make sure that your cluster is compatible with the chart. And then you also want to give room in case you're going to upgrade your Kubernetes cluster. You want to give room and make sure that the chart you deploy is compatible with one version ahead. Generally, I like to keep 2 versions so you're able to upgrade, and you're able to upgrade your cluster without affecting the charts. And once your Kubernetes cluster is upgraded, that'll allow you to upgrade all your Helm charts to make sure you're ready for the next version. So version management for Helm and Kubernetes go hand in hand and are very important. And you'll find that these Helm repositories in GitHub are very similar. They all kind of have docs, they have a charts folder, you can go inside there, and they have the template directory. This is the similar template directory we looked at earlier for our own custom chart. But if you go in here, you'll see all the Kubernetes YAML. So cluster role bindings, controllers, daemon sets, deployments, roles, secrets, services, and so forth. You can deep dive those if you actually want to have a look at the manifests under the hood and what sort of parameters they inject and so forth. But more importantly, importantly for us, if we go back, if we go in this charts ingress nginx folder, right where the template directory is, we have the chart.yaml. This is information about the chart, but more importantly, here are the default values.yaml. So I'm going to open this in a new tab, but this will give us all the default values for this Helm chart that we can go ahead and override. And you can see it is quite large, and generally these types of values files would be up to like 1,000 lines, because the software and these controllers and things generally have a lot of YAML, which means they'll have a lot of customization to support, because the community wants to be able to override almost everything. So you'll find all the overrides in here. This allows you to copy this values file and then customize it and create one for your development cluster or your production cluster. And you can run less replicas in dev and maybe more replicas in prod. Then if we go back to the previous page, it actually shows you how to deploy it. So generally, to deploy things from Helm repos, especially public ones, remember we won't have all the source files locally, and we don't need to grab it locally because Helm has a command called Helm repo, and we can add this repository by doing Helm repo add, give it the name and the URL where this code lives. This is a GitHub IO URL, so we can actually go ahead and copy this. So then I go ahead and paste that. So that command is Helm repo add, the name of the repository and the URL where it belongs, and then we can say Helm repo update. That gets all the updates. Now to search for the versions available in this repo, we can say Helm search repo, the name of the repo, and we can say -- versions. And now you can see it's got all the version numbers over here, and we're interested in the chart version 4.12.1. Remember, this was the number of the chart version we saw on the GitHub page. And then they have instructions on how to install the chart, and that's simple. It's just Helm install, a release name, and then we pass in the name of the chart. So I can go ahead and copy this, go to our terminal, paste that, and as the release name, I'm just going to say ingress. So I go ahead and run that, and then after some time you can see that it has gone ahead and deployed. There's the status, the revision, and it prints out some examples. Now this has gone into the default namespace, which I don't like. Generally with these sort of controllers, they should go into their own namespaces. So what I'm going to do is show you the uninstall command. So I can say helm --help, and what we're looking for is the uninstall command. So then I can say helm uninstall --help, and we can see that this takes a release name. So I'll say helm uninstall ingress, and that's gone ahead and uninstalled it. If we do kubectl git deploy in the default namespace, we can only see our example app, so the ingress is gone. I can actually pass a namespace by doing the helm install again. So we say helm install and our release name followed by the chart. I push -- namespace, and I would like to call my namespace ingress nginx. Go ahead and run that, and you'll see it says create namespaces not found, but there's actually a flag that we can use called -- create namespace. This will tell Helm to create the namespace as well. And if I run that, we can see now that is successful. So it's gone ahead and deployed into that namespace, and it's given us some examples on how to use it. So if I say kubectl in the ingress nginx namespace get pods, we can see our controller now deployed. But this is how you deploy a public Helm chart. Now I've already covered values files, so I'm not going to cover it too extensively again. But if you wanted to change the number of replicas, you can see we have one replica at the moment. If you wanted to go ahead and change the number of replicas, you would create a values file to hold that new replica's value. And you would go onto their GitHub page, and you would go through the values file and find how to switch the replicas. So in their values file, you would go down, and it's under controller. So you can basically just create a values file with this controller object and then put dot, and you can override any of these. But what we're after is the replica count. You can see the default value is 1. That's why we only have one pod. So what you can do is you can create a new values file with a controller item, and then in there you can put replica count as something like 5 if you want 5 replicas. And then to change that, you would say helm upgrade instead of install. So you'd say helm upgrade. You can remove the create namespace as it's already there, and you'd put -- values and point that to your values.yaml. So that's how you would do it over the values. One other feature I wanted to show you is that you can actually use another flag to specify values from like environment variables, maybe some sensitive information like API keys and secrets. You can inject them because generally you don't want to put secrets in a values file, because if you put secrets or sensitive information in a values file, you'll end up committing it to Git, and you want to avoid that. So Helm also allows you to do something like --set, and then you can go ahead and set values. So I can say set my controller.replica count, and I can set that to 5. So I say --set controller.replica count equals 5, and that'll go ahead and perform a Helm upgrade. You can see we now revision 2, and if I do kubectl in the ingress namespace get pods, you can now see we are getting 5 replicas. So you can either use a values file, or you can use --set and set different values over the command line. So that is a Helm overview in a nutshell. If you want to check out the video down below, feel free to check the link in the description where we go into more extensive detail about building your own Helm chart. And throughout this series, when we take a look at open source controllers just like the Ingress Nginx or Prometheus or monitoring or service meshes, we'll use Helm to install these charts. So you'll get to use Helm more frequently and become more confident with it. So if you liked the video, be sure to like, subscribe, hit the bell, and check out the link down below to the Ultimate DevOps course for status updates and progress on development of the course. And if you want to support the channel even further, be sure to hit the join button down below to become a YouTube member. And as always, thanks for watching, and until next time, peace.